Now, before we proceed with programming in MATLAB, let's take a look at relational operators. For example, if we do in MATLAB 5 greater than 8, when we press enter, then MATLAB will return the answer as 0 because 5 is not greater than 8. So this is called relational operators. We can also assign variable. For example, a is equal to 5 less than 10. When we press enter, we get a equals to 1. And MATLAB also include here logical. So this means that a is equal to 1 because this statement is true. So 5 is indeed less than 10. We can also use relational operators in mathematical expression. For example, we have y is equal to 6 less than 10 plus 7 greater than 8 plus 5 times 3, that is equal to 60 divided by 4. So notice here that I put 2 equal sign because in MATLAB 1 equal sign means that it is an assignment. Let's say here a equals to 5 less than 10. We assign a to this expression over here. But here when we include double equal sign, this means that we are saying that this is equal. Double equal means equal. 1 equal sign means assignment. So when we press enter here, we get the value of 2, y equals to 2, because 6 less than 10 gives us 1. 7 is greater than 10 gives us 0. And 5 times 3 is 15, that is equal to 60 divided by 4, which is also 15. So here is true, here is false, here is true. So 1 plus 0 plus 1 is equal to 2. So we can include the relational operators in mathematical expression. We can also use relational operators in vector calculation or in arrays. For example, we have, let's say, b equal to b is a row vector, and then we define another row vector c. So now we do d, that is equal to c greater than equal to b. Okay, so this is our operation here. We want to find out which one is the value of c that is greater than equal to b. So d, when we press enter, there will be another vector of d produced by MATLAB, and the first one is 8 greater than 15 will return 0. Second one is 20 greater than 6 will return 1 is true. 9 greater than equal 9 is true. 2 is greater than 4 is false, and so on. So we can also perform relational operation using array. And we can also check these two elements in these two vector. For example, we say b is equal to c. So we want to find out how many elements in b that is equal to c. When we press enter, we get this value. The first element of b is not equal to c. That's why MATLAB returns 0. Second element is also not equal to c. The third element of b is equal to c. We have here 9. 9 equals to 9. 0, 0, 1 here because 7 equals to 7, and so on. We can also do b not equal to c by typing in this command here. This symbol, this two symbol here represents not equal. So MATLAB will check the values that are not equal, the values of b that is not equal to c. So we get 1, 1, 0, 1, 1, 0, 1. These two element here is equal of these two elements of b are equal to C, the rest are not equal, so it returns 1 because the statement is true. Okay, we can also do, let's say F equal to B minus C, that is greater than 0. So this will subtract C from B and check which elements are larger than 0. So we have 1 here for true, false, false, true, false, false, true. We can also do this with a matrix. Let's say we have a matrix A, that, say this is our matrix A, and then we can do B that is equal to A of less than equal than 2. So a new matrix B will be produced by checking which values, which elements in A that is less than equal than 2. So the first one will return 1 because 2 is equal to 2. The second element is 0, 0, 1, 0, 1, 0, 0, 1. So we can do the relational operation in arrays and also vectors. We can also perform logical operations in MATLAB. For example, we can say 3 and 7. When we press enter, MATLAB will return answer as 1 because both values here are non-zero, so the outcome is 1. If we do, for example, 0 and 1, then obviously the answer will be 0 because we have a 0 here. So as long as there is non-zero or true, the outcome will be 1 for AND statement. We can also say A equal to 5 or 0, okay, and the answer will be 1 because now the logical statement or operators is OR. So one of the variable or one of the number is non-zero, which is 5. So the answer written here is 1. We can also say, for example, not 25. And the outcome will be 0 since 25 is true, there is non-zero, and the opposite is false. We can also use logical operators in mathematical operations. Let's say, for example, we have this operations here. When we press enter, we get 50 because 12 and 0 is equal to 0 plus not 0, that is equal to 1, plus 0 or 5, this will be also equal to 1. So 0 plus 1 is 2, and then 25 times 2 is equal to 50. And we can do the same for vector. Let's say we have these two vectors x and y, and we can do x and y, which will perform logical operation here. So 9 and 2 will produce 1 because both are non-zero. 3 and 0 will produce 0 because here is obviously 0, and so on. And we can also assign a variable. For example, z is x or y. So we get this. And also we can do, for example, not x plus y. And we get this answer here. Now let's take a look at the conditional statement, and in this case we are talking about the if conditional statement. Now what we want to calculate here is how much, in this example, what we are calculating is how much a worker is paid based on his working hours and also based on his hourly salary or wage. So the input here is time or T, how many hours he has worked, and also how much is he being paid for every hour that he has worked. So pay is equal to T times H. That is the normal calculation. And there's another condition here. if the worker has worked for more than 40 hours, then the extra hours that he has worked is considered as overtime, and the overtime is paid 50% of the normal hourly wage. So that's why we need a condition here, a if statement here. So here we say if time worked or working hour T is more than 40, then pay is no longer equals to pay is no longer equals to T times H, but pay now is equal to pay up here, the normal payment, plus T minus 40, the extra hour that he has worked, times 0.5 or 50% times the H, the hourly wage. And then we use and then we put N here to end the conditional statement, and we print the output using the fprintf command. So let's say I run this script here. So MATLAB asks, please enter the number of hours worked. Let's say he has worked for 35 hours. And then we need to enter the hourly wage in dollar. For example, he is paid $8 per hour. So in this case, the script will be executed only up to here, and it will skip the if statement because in this case, the working hours does not exceed 40. So T input, H input, then calculate the payment, 35 times 8, we get 280, and then MATLAB will straight away print the output. But let's say we run this again, and the working hours is now 50, for example. And then the hourly wage is 10. So according to T times H, we should get 500. But in this case, when we press enter, MATLAB gives us 550 because of this conditional statement here. So initially, he has 500 ringgit payment here, or $500. And since he has worked for 10 hours more, T is 50, that is more than 40. So payment is equal to T minus 40 is 10 times 0.5 times H, which is 10. So he gets another $50 extra. That is why the worker's pay is equal to 550. So this is an example of how we can use a conditional statement or if-and statement in our programming in MATLAB. Let's take a look at another example that we can use if statement. So now this is the problem. We want to calculate the water level in a water tower. So the tower has a shape of a cone on top and a cylinder at the bottom. So for the height of the water from 0 until 19 meter, the volume is given by the volume of a cylinder, which is V is pi times 12.5 squared times H. H is the height of the water. But for the height of the water from 19 until 33 plus 14, the volume of the water is now given by adding the volume of a cylinder with the volume of the water in a cone for H is equal to 19 meter. So the formula now becomes this: V equals to pi times 12.5 squared times 19. This is the volume of the full cylinder up to 19 meters plus the volume of the cone up here. 1/3 of pi times H minus 19 times 12.5 squared plus 12.5 plus RH squared, where RH is 12.5 plus 10.5 over 14 times H minus 19. This is how this equation is derived from this cone shape here. So when we program the solution for this, we need a few conditions. So let's look at the programming to calculate this. The first one is that we ask for an input. So please enter h is equal to input. Please enter the height of the float in meter. So how high the water level is in the tower. Then we start with our conditional statement. If h is more than 33, which doesn't make sense because the height of the water tower is only 33. So if someone enters a number that is more than 33, we want MATLAB to display an error. So we say if h is more than 33, display error. The height cannot be larger than 33. That is our first condition. Else, if h is less than 0, which is also not logic, or if h is less than 0, let's say the input is a negative number, we also want to display an error. So again, display error, the height cannot be a negative number. Then comes our third condition, else if h is less than equal to 19. So according to our formula here, if h is less than equal to 19, this is how you calculate the value of v. So v is pi times 12 over 2 over 12.5 squared times h. So else if h is less than equal to 19, then v is pi times 12.5 squared times h. And then we print the volume of the water is with 7 digits and 3 significant figures in cubic meter, taking the value from the variable v here. Then comes our final condition, else if h is larger than 19, else we don't need to put anything because we have put all the constraints here. H must not be more than 33, must not be less than 0, and if it is from 0 to 19, this is the volume to calculate. Else, which else here means that it is more than 19 but it is less than equal than 33. So this will be the equation. First we need to calculate RH according to this. So RH is 12.5 plus 10.5 over 14 times h minus 19. This is what this formula calculates. And then when we know the value of RH, we can substitute into this equation to calculate the velocity. So here we have v is equal to this equation here that involves RH. So this is our equation here to calculate the velocity for this condition. And then finally we print f, the volume of the water is with 7 digits, 3 decimal places, cubic meter. So let's try run this program here. When we press run, please enter the height of the float in meter. So let's say we put in 35, which is more than 33 meter. MATLAB will go to the first condition. H is more than 35, then MATLAB display error, and automatically the script will go to end. When we press and when we run this again, enter the height. If we do -5, for example, MATLAB goes to the second condition. H is less than 0. Also, it will display an error. If we put in, for example, a number that is less than 19, let's say I put in 10. So MATLAB calculate the volume of water is 4008.739 cubic meter. It only goes up to here, and after printing the result, it will straight go to the end. And if we run again and we put in number that is greater than 19, for example 25, we get this answer calculated using this formula here. So the volume of water now is 13,459.368 cubic meter. So this is called nested condition. We have a few conditions. or this is also known as if-else-if structure. We have if-else-if-else AND structure, and this is another way that you can program in MATLAB using conditional statement. Now let's take a look at another programming statement in MATLAB, that is switch case. So in this example here, we would like to convert the value of energy from one unit to another. So if you look at the first line here, E-in is asking the user for an input. Enter the value of energy or work to be converted. So one will enter the value of the energy input. And then the next line is asking the user to enter the units, E-in units. So this is equal to input, enter the current units in joule, foot-pound, cal, or EV. And then this comma S here means that the input that will be entered from this line here will be considered as a string. It is not a number, a value. So this is why here we put comma S within apostrophe here to state that whatever values that is being entered from this line is considered as a string. The third line is asking another input, what is the output unit? So enter the new units. Current unit, for example, in joule, and we want to convert it into, let's say, foot-pound. So this is the input command. Enter the new units, J for joule, foot-pound, cal, or EV, and also will become a string as well. So now we go into our statement or condition. So first we set the error as equal to 0. So this will set the error to be equal to 0. Set the initial error equals to 0. Then we go to switch case. Switch case means that MATLAB will automatically switch into specific case according to the input. So here we have 4 cases, J for joule, foot-pound, cal, and EV. So let's say the input is in joule, then MATLAB will switch into this case. And otherwise, if the unit entered is other than these 4 units here, then MATLAB will display an error. So error is equal to 1. That is why we have otherwise here. So this is for the input unit. And then we have another switch case for the output unit. So for output unit, also we have 4 cases, and also otherwise. If the user enters something other than these 4 units, then we will also return an error. And then finally, MATLAB, finally we have a condition here. If there is an error, if error, or if error equals to 1, or we can just type in if error, then display error, current or new units are typed incorrectly. Else, we print out what is the value, fprintf, E equals to E out and also the E out unit. Let's try to run this script here. So enter the value of work to be converted. Let's say we want to convert 100 from unit foot-pound into joule, for example. Then MATLAB will enter E equals to 135.501 joule. So what happens here is that in the first line, we enter the value equals to 100. Second line, we enter foot-pound. Third line, we enter joule. So MATLAB will go to the first switch case statement, and we look at the E-in unit, the input from the second line. Our input from second line is foot-pound. So MATLAB will automatically switch to this case here. So foot-pound, EJ is equal to E in joule is equal to E in divided by 0.738. And then we want the new unit. Then MATLAB go to the next switch case statement. E out unit, now we want in joule, so E out is equal to E joule. So basically the idea here is to convert everything into joule and then display it again based on the user preferences. So here the first switch case statement is converting everything into joule. That is why you see that if the input is already in joule, E joule is equal to E in. So nothing has been done here. And then finally, we check for the error by using the if-else statement. So now let's take a look at loops in MATLAB. There are two types of loops that we can perform. The first one is for loops and the second one is while loops. Let's start with for loops. So in for loops, for example, we type in for k. K can be any number from 1 with increment of 3 until 10. Then we type in our mathematical expression, x is equal to k to the power of 2, for example. And then we type in end to end this loop. So when we press run, we will get a few outputs of x. The first one is the first iteration, k equals to 1, then x will be equal to 1 to the power of 2, first iteration. Then it goes to the second iteration. Second iteration is 4, because with increment of 3, so the next value of k is 4. Now x is then 4 to the power of 2, or 4 squared is 16. And then MATLAB goes to the third iteration. Third iteration will be k equals to 7. Now x is equal to 7 squared, then we have 49. And then the fifth iteration is when k is equal to 10. So then x is equal to 10 squared, we have 100. Then only MATLAB will end the loop because we have reached the maximum value of k. So this is how loops in MATLAB works. So this is what we have for loops. Okay, now let's take a look at while loops. So to perform while loops, we need to define first the initial value. So we define x equal to 1. This is the initial value. Then we say while x is less than equal to 15. So for while loops, we know we define the last iteration. So while x is less than equal to 15, the mathematical operation is then x is equal to 2 times x, for example, and then we put this to an end. When we execute this script here, we will get this value. Initially x is equal to 1, then it goes into the while loop. While x is less than equal to 15, so x is equal to 2 times 1, and then it goes back. Now x has a value of 2, then x is equal to 2 times x, or 2 times 2, now it becomes 4. Then it goes up here, x is now equals to 4, still less than 15. Then it will execute this expression. Now x is equal to 2 times 4. Now you get 8. And then it will go to the loop again. Now x is now 8, which is still less than 15. So the new x is equal to 2 times 8. You get 16. Then it goes again up here. Now x is now 16, which is now greater than 15. So because it does not satisfy this condition, then MATLAB will automatically end the loop. So we only have the x value up until x equal to 16. So that is how you perform a while loop. So the difference between for loops and while loop is that for for loop, you define the number of iterations by defining this number of iterations up here. For while loop, we define the maximum iteration. So when this maximum number is reached, then automatically the iteration will be stopped. We can also program loops within a loops or conditional statement within a loop. So this is called nested loops or nested conditional statement. For example, here we want to create a matrix A. We want MATLAB to create a matrix for us. So the first line here is asking the input of number of rows. The second line is asking the input of number of column. The third line here define an empty matrix. So we say A equals to an empty square bracket, which will produce an empty matrix. And now we start our first for loop. So for k is equal to 1 until n. N is the number of rows. And then we go to the next for loop. For h is equal to 1 until m. M is the number of column. And then we have a conditional statement in here. If k is equal to 1, we start the conditional statement. If k is equal to 1, then a is akh is equal to h, which means that we assign the values to the elements of the first row. Else, if h is equal to 1, akh is equal to k. We assign the values to the elements of the first column. Else, akh is equal to a k, h minus 1 plus a k minus 1, h. And this n here refers to the end of the conditional statement. This n here refers to the end of the inner for loop. And this n here is the end of the outer for loop. So if we run this script here, MATLAB asks the number of rows. Let's say we do 3 rows by 3 columns. When we press enter, MATLAB will produce a matrix A that is 3 rows by 3 columns. We can view the steps or the iterations in the loop by creating breakpoint. For example, let's go to line number 6 and we go here breakpoint and we set a breakpoint here. And also we want to look at the breakpoint for the if or the conditional statement. So I set 2 breakpoints here, and let's see what happens when we run this. So let's say we want to create a 3 by 3 3 rows and 3 columns. So this is the first 2 lines of the input. Okay, when I press enter, now MATLAB creates an empty matrix. So you see in the workspace that A is empty. Now M and N is the one that we define here. N is 3, M is 3 here. And then it goes to the first loop. For k is 1 until n. So basically k is 1 until 3. So it starts with k equals to 1. Then when we continue, you see that now h appear here. First loop is k equals to 1. Then it goes down here, h equals to 1. So h equals to 1 appear here. When we continue again, now A is equal to 1 because now h is equal to 2. So it is currently looping in the inner loop. So h now equals to 2 when we press continue. So now the if statement is still in here. So if k is equal to 1, because k is still equal to 1 now, k is equal to 1. So a is akh, so a1h is now 2 is equal to h. So we assign number 2 to the second column first row of matrix A. When we press continue, now MATLAB assigns another number to the matrix. Okay, now H is 3, A is 1, 2, 3. Now it has go to the outer loop again. Now K becomes 2. See here, K becomes 2. When we continue, now it goes down. H now becomes 1. And then MATLAB produce the first value of the second row of matrix A, now 2. And then the third and fourth column, the second and third column is still 0 because it has not go through the iteration yet. So as we continue, each number is being included in the matrix until we arrive at the final stage of this iteration, and finally the final matrix A is produced with this 3 by 3 matrix.